these new fitness trackers to its product line, a glance at the data is enough to see that the sales of both types of fitness trackers are increasing. Unfortunately, the store has limited space for the merchandise. The manager decides that the store will sell both models until the sales of TrekSmart exceed those of the Fit Tracker. Find an equation of an exponential model that models the sales for each fitness tracker. This would be kind of a review item, wouldn't it be? How many points did we need to come up with the equation y equals ab to the x? How many points? I heard you. Say it louder. We needed 2. You get to pick your coordinates. Now, I think it's best if you pick them farther apart than closer together. So we're probably going to pick 1 and 28 and 4 and 228. And we'll come over here and do this one, 1, comma 5. And 4, comma 130. And what did we do with these kind of points? Which one did we start with? We always started with one particular one. Highest x value. All right. So when we do that, we have 228 equals ab to the 4th. And 28 equals ab to the 1st. And what did we do with these two equations? We divide them. Thank you very much. And so, of course, we're going to take a calculator because nobody knows 228 divided by 28. Well, not a whole lot of people in the world. Maybe the geniuses, but not me. So 8.143 is equal to what? What's over there on the right side? Anything cancel out? The a's, and so we're left with b to the 3rd. How do we get rid of the 3rd power? We take the cube root. Thank you very much. So we're going to do it in an ugly cube root, 3 math. And we take the cube root of the nastiness and get 2.012. And so we have an equation. We will do the other one tomorrow. But do we know the a value? Or do we only know the b value? So far, we only know the b value. Tomorrow, we're going to find the a value and finish the other one. How do we find the value of a that goes with it now that we found b? Plug what in? Do you have a preference of any equations? Nope. Probably the one with the smaller exponent. Smart idea. So 28 equals a times 2.012 to the 1st power. Use a calculator. Find it. Go. I'm going to have to just move on and figure this out at lunch. Why isn't it unfreezing? There we go. Nope. Come on. Unfreeze. There we go. Okay. So when I divided it, I got 13.92. All you're doing is division of the 2.012. Sorry, I smushed all that together. That looks gross. So my a value ended up being the 13.92 value. So my model is that one right there. Now, they wanted us to do the same thing with the other one, the TrekSmart situation. So Start to finish, take the two coordinates. Which equation should we, or which coordinate should we start with? Which coordinate should we plug in first? Come on, I gave you a very specific rule. The bigger what? The bigger x value. It has nothing to do with the y value, folks. It has everything to do with the bigger x. Just write that down to remind you. Get this thing finished. Find that model. Funk, do you have a particular equation out of the two that you would like me to use? That's a great choice right there. Folks, use the one that's the easiest for you to use. Make your life simple as you can. Right? And then obviously you're just going to divide that to the other side. $1.688. If you leave it like this, why do you lose credit? If you leave your work like this, why are you going to lose credit? You need the model, folks. I need to know that you understand what an exponential function looks like. And that you understand where these values go in the function. Which one's growing faster? Fit Tracker or TrackSmart? TrackSmart is growing faster. What do you look at to make that determination? The B value, right. What percent is it growing by? What percent is it growing by? Remember, we go from 100% all the way up to 296.2%. What percent did we go up by? 196.2%. All right, example 1, which I need to unfreeze the screen for. Otherwise, you can't see it. Oh, stop that. Stop it. There we go. I want to solve this exponential equation. Is there a common base for 1/2 and 4? Is there a common base for 1/2 and 4? Some number that you can think of that you could rewrite 4 and 1/2 also. 2. Any ideas? 2. Oh, nice job. Good job picking up on the hint there. Yes, we can write 4 as 2 to the what power? 2 to the second, right? Okay. And we can rewrite 1/2 as 2 to the negative first. That's right. You know, you could, let's see here. Let me split my screen. Suppose I was trying to do some of this algebra. Let's try this. Suppose I was trying to do some of this algebra and copy and paste it over to Magic School AI. I know. I can see the eye rolls over there. I'm not going to look this direction because of that fact. But if some of you want to try something, like you're trying to use the Magic School to kind of get a next step, you can use this, the Desmos Scientific, as a way to type the algebra. So if you're just, you're trying things out, you're trying to figure out, okay, does this work? And I want to see if this works. And I want to ask it the question. And I want to see if I did it right. So if you are trying, this is a strategy you could use, because you literally could then take this snippet and paste it into and say, is this the correct first step? Okay, it can analyze the picture. Now, could you, if you were using a phone, could you take a picture of your written work and upload it and have it check to see if you are doing the first step correct? Yes, you could. But this is another way to do it. Okay, it will go through and look at it and analyze it and tell you if you did it right or wrong. It's not going to be giving you the final answer, but it will, allow you to take that next step and at least have some assurance in your heart that you're doing it right. What I'm hoping you see is this and this. What do we have on the left circled in red? What do we have on the left circled in red? Come on, folks, what are you allowed to do with the power of a power? Multiply. Multiply those two things together. What is -1 times x plus 7? Negative x minus 7. Negative x minus 7, that is true. All we did was distribute the -1. And on the other side, we have 2 to the 6x. That's true. What do we need to do now? We can literally ignore the bases. Thank you for your suggestion. It's not really canceling, but you are ignoring them. And you're saying, I'm going to set an equation where I'm only comparing the exponents because I know that these two things have to be equal. Otherwise, this can't be true. Okay, solve it. So hopefully you added x to the other side and you added x to this side and got -7 equals 7x, divided out to 7 and got, oops, sorry, that's +7. Got x equals what? -1, that's true. That is true. Good work for the ones that I looked at. I'll try to get around the room to see other ones on our next example. Any questions on that? Example 2, how can you rewrite this equation using logarithms? We do not have a common base for 17 and 4. I've already taught you how to do this, so this should be just, kind of reminding you. If you can't solve it as an exponential, what are you going to change it to? Logarithms, right? So we used boxes. Obviously, you don't have to use boxes if you understand what's going on. What's the base? Your choices are 17, 4, or x. 4. The exponent goes on the other side. Is it 17 or x? It is x, which leaves one box left. Please, please, please try not to cross that line. 17 doesn't look like it is, a hot air balloon. It should be at the same level as log. Only thing lower than that is the base. We talked about the change of base theorem. What does it mean? Or what do you get? How do I use it? Come on, stay with me. How do I change that to something I can use my calculator with? I'm looking for this on the test. Any test or quiz, I'd be looking for this one step. What is it? Something to, I'm going to create, you can see there's a fraction bar, right? So there's going to be something on the top and there's going to be something on the bottom. Can you remind me? Log 17 over log 4. Change of base says we can pick any base we want. What base did we pick? 10. We chose base 10 because our calculator can handle it. And so now you should be grabbing a calculator. Like some people in the front row. Nice job. And actually dividing it out to find the weird decimal. Because it's not obvious. Okay. I typed log 17 over log 4 on my calculator. How come I didn't get 2.04 like you did? Oh, so I forgot an end parenthesis on the 17. And yes, folks, it does change the answer. If you're using a horizontal style like this, do not forget that parenthesis, or you'll get it wrong. Now, if you're using a vertical style like this, Desmos Scientific or something like that, or your handheld does vertical fractions, that's fine. So like something like this. How did I know the answer was going to be between 2 and 3? Without doing anything, how did I know the answer was going to be between 2 and 3? I didn't know what it was, but I knew it would be between 2 and 3. Yeah, 4 squared is 16, but 4 cubed is 64. Now, does it make sense that this is going to have to be closer to 2 than 3? Yeah, because 17 is a whole lot closer to 16 than 64. What do you think this triad's going to be between? 5 to the x equals 12. What do you think it's going to be between? Don't tell me what the decimal is. I don't really care. What?
1.5 and 1.6.
Ooh, we're just making random guesses here? I don't know what 5 to the 1.5 is. I'm not typing on a calculator, folks. I'm just trying to get a basic feel for what it's between. Give me integers. 1 and 2. Yes, it's going to be between 1 and 2. All right? So it may be between 1.5 and 1.6 if I use a calculator, but I just don't know those numbers off the top of my head. I do know 5 to the first. I do know 5 to the second. Learned those a long time ago. Okay. What are we going to do with this? Did you know that you can take the logarithm of both sides of this equation? Did you know you could take the log of both sides? I mean, you know how you can add 5 to both sides of an equation, and you can multiply both sides of an equation by 2. Did you know you could take the log of both sides? Well, if we did that, now what base did I choose, by the way? I chose 10. Why did I choose 10? It's easy because I got my calculator. What is King Julian screaming at me right now? Move those exponents. That's right. Move the exponents down in front. Now what? Now, believe it or not, I'm going to distribute log 3. I know, that's kind of ugly looking, right? X log 3 plus log 3 equals x log 5. It's on a previous question. What do you think you have to do with this one? Yes, say it louder on my right. I heard you. Subtract it. Subtract it. If that's what you were thinking, excellent idea. Because in a previous question, you and I got the x's on the same side. Remember, it was 7x a few minutes ago? Well, yeah, folks, I understand it looks ugly. So we got x log 5 minus x log 3. Do the two things on the right-hand side have anything in common that you could factor out of both of them? An x. That's right, folks. We're going to use the distributive property backwards. All right, that's all you're doing. You know, you took a GCF out. Now, for those of you who think this is, this is an impossible question, log 3 is approximately 0.477. Yes, I know it's an ugly number that keeps going on and on and on and on and on. Can I figure out what log 5 minus log 3 is on my calculator? Yes, I can. And I get 0.22, I guess it would round to 2 if I went to the thousandths place. This is the equation you have to solve? I bet you can finish it. Go. Sides. We had to distribute, get the x's on the same side. If you want to change those into decimals sooner than that, Like, let's suppose right here at this step where I'm pointing at the purple box, you decide to change those all into decimals. It's okay, folks. If it makes more sense to you to change those all to decimals and then keep going, do it. I would be okay if you did that. Once you get them to the decimal point, it's pretty easy from there. So I know we already did question example 1, but I wanted to go back and look at what I think is a better way to handle the question. So we've mentioned the idea of taking the log of both sides. And I know this question was a pretty easy one because 1/2 and 4 can both be written to a power of 2. So we already know the answer is -1. But if I do take the log of both sides and then I follow property 3, which is King Julian's property, where we move the exponents down in front, then my equation looks like this. X plus 7 times log 1/2 equals 3x times log 4. Okay? Now, in an upcoming question, example 3, I taught you how to distribute. And when I thought more about that later, I realized that I think there was a better way. And so I'm showing you in this example. Instead of distributing that, what if you divided by that? And you got rid of that log 1/2. Then the only thing left on this side is x plus 7, which is kind of nice. It's very simple. There's no nasty decimals. How many x's do you see on this side? And, a lot of kids' typical answer is just 1x. Well, what they're failing to do is they're not actually typing 3 log 4 divided by log 1/2. And if you're using a horizontal style calculator, it might look like this. 3 log 4 divided by log 1/2. When you do that, you get -6. So we get -6x on this side of the equation. Much, much nicer. And then, of course, we can bring the x over and get -7x, and then we can divide by -7, and oh, look, we get -1. So instead of doing distributing, which now I'll flash forward to example 3 so you can see that, because in example 3, which I did yesterday, you remember how I did a very, very ugly process right here of distributing a log 3. I would not suggest doing that. So here's what I showed you. I'm going to show you on this side. Instead of distributing, why don't we do division by log 3? Notice that those two things are going to cancel out. And then we can look at this purple circled area and say, how many x's are on the right side? And the answer is approximately 1.465. That's what our calculator would tell us. If you take log 5 over log 3, it's a long, nasty decimal, but you get 1.465, blah, blah, blah. And so we just rounded it off. Well, the other side just have x plus 1. Much easier to work with. Instead of having nasty decimals and ugly-looking algebra all the way through, which is what I kind of did yesterday, just divide out that log 3 and then get a simpler equation, and then put your x's on the same side by subtracting, and then do the division at the end. You can look at the two answers and you could see how similar they are. The only reason they're slightly different is because of a rounding issue that happened inside the problem. So here in example 4, we have obviously a wild forest fire. These are wildland forest firefighters. I'm not sure I'm using the right term. They're obviously not construction firefighters or building firefighters. Anyway, so they are, it says that they can fight this fire. They can contain 160 acres fire without needing additional resources. Okay, obviously they have they have their own equipment. How many minutes does it take for the fire to become too big for that fire department? And they will need to call in additional resources, other fire departments, or maybe helicopters and things like that. So they give me several coordinates, which I can see listed right here. And you're going to need to use two of them. You just have to use two of them. Now, I think the easiest, I think the easiest two to use are these two. And you have to realize that, that the time element is like your x. So it's time, comma, and then the number of acres, which is y. So I would use my two coordinates, and you can see down here it says find the model. That's the first thing you need to do is find the model. Well, we already know how to do that. We take two of our coordinates and we plug them in. We always start with the highest x value, which in this case, if I choose 1, 7.2, then I would use that equation first. And then plug in the 0, 4, and then of course we're dividing them because we, exponential functions are based upon multiplication. And when we divide them, we can see that, let's see here. We can see that the a values cancel out. Of course, you get 1.8 on the left, and the a values cancel out on the right. And you subtract the exponents, 1 minus 0, and you get 1. So now you know the b value is 1.8. What's the a value? Well, I've taught you to plug it back in, right? You take that 1.8, plug it back in. Does it matter which equation you plug it back into? No, it doesn't matter which equation. You can pick either one. Now, I would hope that you would realize that they handed you the b value, right? Remember, the y-intercept is the a value. We already know the b value is 1.8. But if you didn't, you can always plug it in to the equation. Of course, 1.8 to the 0, that's 1. And so now you know that the a value is 4. And so you have your equation. Y equals 4 times 1.8 to the t power. Well, in this particular equation, we have a number of acres of 160. And they want me to solve for the time. And so we just discussed as a class, what are we going to do first? And we decided that we would divide by 4. So if we do that, we are at 40 equals 1.8 to the t power, and now we're ready to finish the question together. Okay, so we decided we were going to divide by 4 when we last left, right? So we divided by 4, right? We took 160, divided by 4, we got 40. Pretty simple, straightforward. The big question you have is, what are you going to do now? What are we going to do to both sides of the equation? Come on, what were we talking about? Log both sides, right? So that's what you should do right now in your notes. Take the log of both sides of the equation. Which base are we going to choose? Which base are we going to choose? Because we get to choose. We're going to choose base 10 because our calculators can handle it. So choose base 10 right now. Take the log of both sides. At this point, this question looks an awful lot like example 2 does. So you could look back in your notes at example 2 and keep going. Go. Okay, now remember, if you look back at example 2, I showed you 2 different ways to do this. One of them would be log 40, you're taking the log of both sides. So some of you were using this method, and then you used King Julian's property where you take that and move it down in front. And then you divide both sides by what? Log 1.8, which we all know is a nasty, ugly decimal, and nobody knows what it is. But you're literally going to type this on a calculator, and some of you are telling me 6.28, right? Okay, now remember, that is one of 2 different ways I showed you. The other way was simply to change it to its log form. I saw somebody do that, which was a good method too, right? I like that one too, because you're using skills that we talked about before. The base is 1.8. The exponent is t. The argument, which is the only box left, is 40. And of course, you can't solve that as base 1.8, so you have to use, there's going to be a problem on your quiz and eventually on your test that says use the change of base. You cannot forget about that method. So what does this turn into if you use the change of base? You wrote it down. Log of the argument, log of the old base, which is log 1.8. And we can see that we got the exact same result no matter which way we did it. We got 6.28. So, quite honestly, at that point, I don't care which way you go with the question. But every one of us should have started this question out by dividing by 4. And some people choose to multiply 4 and 1.8 together and ruin the question because it's not true. So, 2 different ways to handle it once you get the 4 out of the way. How many minutes are we talking about? Remember the problem? How many minutes? What's this problem about, folks? We got less than 6.28 minutes to get this thing under control. Otherwise, we have to call in other fire departments or we have to have a helicopter come in and dump water on this fire. We don't have a lot of time. Now, I do think it's kind of ironic that we're talking about logarithms and logs. Don't you think that's a little ironic? Okay, sorry, that's a dumb dad joke. But, and I don't think that you have Woodland 4 firefighters who are actually calculating how many minutes we have before we need to call somebody. But this is the math behind things. Next. Do we have a single log on the left side? Do we have a single log on the left side of the equal sign here?
No.
Well, I beg to differ. I don't see 2 logs over there. I just see 1. Do we have a single log on the right side? Yeah, we do. We have 2 single logs here. Do you know what to do with this? Well, let me ask you this question. If the left side equals the right side, now don't say divide by the natural logs, but I do understand what you're getting at. Can we ignore the logarithms and just write one equation that only compares the arguments? Can you tell me what x squared minus 16 equals? What does x squared minus 16 have to be? Doesn't it have to be 6x? If these 2 logarithms are equal, then the arguments must be identical. So in other words, I know you're not dividing by logarithms, but we can ignore the logs because we have a single log on both sides with the same base. By the way, what is the base of this logarithm? Nope. E. Thank you very much. Thank you very much. Natural log, man. Remember, naturally. That's my dumb way of trying to remember it. Right? So, we literally are going to ignore it. The logs. Well, now what are you going to do? What's my hint to you with that blue arrow? Subtract the 6x, right? So that we can do what? Maybe something we did last semester? Factor it? If it doesn't factor, what's your backup plan? Quadratic formula, thank you very much. But I'm hoping this thing factors nicely. I mean, I really don't want to go through the quadratic formula if I don't have to. So see if it factors. Go. So I had many of you doing this, right? Good job, nicely done. And of course, you'd set the factors equal to 0 and solve them, right? Because that's the only way you can handle this situation. Of course, many of you wrote down x equals 8, x equals negative 2, and then I said that there's only one answer, and then some of you were stuck. Why? Why is 8 the only possible answer here? What happens if you take negative 2 and plug it back into the original equation? You cannot take the logarithm of a negative number, folks. I mean, take this thing and plug it back in. You're done right there. That's an extraneous solution, right? This one's extraneous, so we throw it out. Only one answer. All right, next. Yep, go for it.
5b on triad.
Okay. So similar situation there. We would take the negative 4x minus 1 equals 4x squared. And then, of course, we're going to move everything over to the other side. 4x squared plus 4x plus 1 equals 0. Okay, so far, does that make sense, what we're doing? Did you have a question from that point? You would have to factor it, right? So you'd have 2x plus 1 and 2x plus 1, right? That's the only way to factor that. So if you set the factor equal to 0, since it's the same factor, you don't have to do that more than once, right? What do you get? We get negative 1/2. Now, before you start screaming at me that there's no solution here, we better check. What happens when you take negative 1/2 and square it? It becomes a positive. So that side's going to be okay, right? What happens when you take negative 1/2 and plug it in here? It becomes a positive also. Oh, so it worked. X equals negative 1/2 does work.
What about for 5a?
No. I mean, I do see that when you plug it back in on one side, it gets squared.
What about 5a?
Okay, now, there are no questions. Listen to me. There are no questions on the quiz. I just looked it over. That your quiz review doesn't show any questions about graphing. Because I'm not going to have you pull out the graphing calculator and graph the doggone thing and see where they cross. You definitely can use Desmo Scientific. It's not a bad strategy at all. Okay, so don't need to worry about the graphing part. Okay, so we'll skip that.